Hi YouTube, Tim Eckert here. In this video we're going to go through an equation that's giving us speed either after a car begins to accelerate or decelerate. And we're going to figure out what the speed is. This is a type of problem that you might see on the SAT, and it's inspired by a College Board question that I saw on practice test 10. I'll leave a link to the College Board tests in the description. Okay, let's get started. Let's look at this first one. We've got this equation, s equals 55 plus 2t. And the question reads, the equation gives the speed s in miles per hour of a certain car t seconds after it begins to accelerate. What is the speed in miles per hour of the car 3 seconds after it begins to accelerate? Okay, so t equals 3 in this particular case. So we're going to fill in 3 here in this equation. We're going to say the speed equals 55 plus 2 times the time, which is 3 seconds. Okay, so it's going to be 55 plus 2 times 3, which is 6. So our speed here is going to be 61, and that's miles per hour. Sweet. Okay, so let's take a look at another one. Okay, we've got an equation s equals 55 minus 4t. So the equation gives the speed s in miles per hour of a certain car t seconds after it begins to deaccelerate. What is the speed in miles per hour of the car 5 seconds after it began to decelerate? Okay, so the time is 5, so that's going to go right there. We're going to put 5 where t is. So we're going to say the speed equals 55 minus 4 times the time, 5. So our speed equals 55 minus 20. 55 minus 20 is 35. So our speed 5 seconds after the car began to deaccelerate is 35 miles per hour. Awesome. Let's try another one. Okay, we've got an equation s equals 42 plus 9t. The equation gives the speed s in miles per hour of a certain car t seconds after it began to accelerate. What is the speed in miles per hour of the car 11 seconds after it began to accelerate? So the speed is going to be 42 plus 9 times the time here, which is going to go in here. So it's going to be 9 times 11. So our speed is going to be 42 plus 99. Hopefully this is on a racetrack. So the speed is going to be 42 plus 99, which is 141 miles per hour. Awesome. All right, let's go to our last problem. And I made a little mistake here in my wording here. This should be deaccelerate. So deaccelerate. Same with this. Deaccelerate. And the reason I can tell that is because we have a minus and a number times the time. So deaccelerate. We'll pretend I did that mistake on purpose. Okay, so we've got the equation s equals 100 minus 10t. The equation gives the speed s in miles per hour of a certain car t seconds after it began to deaccelerate. What is the speed in miles per hour of the car 8 seconds after it began to deaccelerate? Okay, so we're going to put the 8 where the t is, right there. So we're going to say the speed equals 100 minus 10 times 8. All right, so we started off a bit hot there at 100. Hopefully we're on a racetrack. So 100 minus 80 is going to be 20 miles per hour. Perhaps we're pulling into the racetrack's pit area. Anyway, so that's the answer for that one. Hopefully you enjoyed these sets of problems and it helped you out. If you did, please like and subscribe.